Civil Engineers Choice, our YouTube channel. Already I have uploaded four videos. First for the prerequisites of strength of material, and two videos are related to basic things which are required for the simple stress and strain, and third one video is on the general numerical to calculate on the calculation of elongation and stresses. Now I am uploading next video, that is part 4, and in that video we will discuss the elongation of uniform cross section bars with the intermediate axial force. In first part we have discussed the numerical on the elongation and stresses, and in this video we will discuss about the elongation of uniform cross section bars. Uniform cross section bars means the cross section that already we have discussed in the previous video. So basically so many types of numericals are there in the uniform cross sections bars with the intermediate axial force. So due to the time period I have divided these types of numerical means videos on this type of numericals in two parts. So first I will discuss some numericals, 2 to 3 numericals in the first part, and in the second part where we can say it's a 4.1, it's a 4.1, and the next one will be the 4.2. so two videos will be there, so we will discuss about that videos. So I have divided these types of numerical in two parts, 4.1 and then 4.2. It means we will discuss the numericals related to this type in the two part, okay, only because of the time required for the video, okay. And following are the some topics on which we will upload some videos in upcoming days. So let's we will start with the numericals. So these are the list of contents already I have discussed in the previous some videos. So these are the total contents that already I have discussed in the previous videos, and this is the theoretical part which are very important to solve the numericals. So in that parts I have discussed some basic parts, some numerical some formulas which are useful for the numerical. So let's go through the videos. I will give the link of all the previous videos in the description box for your review. Please subscribe it or like this channel. Then this point is also already I have discussed in the previous videos. The types of numericals related to simple stress and strain I have divided into two types. Now first we are discussing this one, okay, first part. Then next one is the formulas which are important for the first part, general numerical. For the general numericals and stresses calculations, these are the formulas which are important, already discussed in please see the previous videos. Now the comes to main point, that is 12.2, that is the numerical on the elongation of uniform cross sections bars with the intermediate axial force. So before starting numerical we will see some basic things which are required to solve the numerical, okay. The first thing is what, in such type of condition bar is divided into subsection and calculate the internal axial force for each section and then elongation. So see, basic numerical is what, to calculate the elongation of cross section bar, but main thing is what, whatever bar is given to us, that bar is divided into subsection, okay. That is A to B is the first section, B to C second section, and C to D is the third section, okay. So these three sections, just I have taken this simple diagram for the example only. So this diagram or this whole section A to D, this section is divided into three part, A, B, B, C and C, D, okay. And some intermediate forces are given, that is F1, F2, F3, F4. These are the intermediate forces. F1 and F4 you can consider forces as the external forces, but F2 and F3 both forces are the intermediate forces. So such type of sections will given to us, and for such type of force system and the sections, we have to calculate the stresses and the total elongation of this bar. Okay, now to calculate the total elongation of such type of bar, first we have to calculate the change in length or the elongation of each section. So here I have divided this total section in sub part, that is A, B, B, C and C, D, and then just calculate the elongation of each section. So delta L AB, delta L for BC section and delta L for CD section, means change in length for AB, BC and CD section separately, and then take a sum of all these section. We will get the total elongation of that particular section. Now we know how to calculate the change in length of the particular bar or particular section. Formula is simple, that already we have discussed, that is PL by AE. Formula is what? PL by AE. Okay, this is a simple formula that we have discussed. Okay, but now here we are calculating elongation of particular section. That's why we have just modified this formula with the section. That is, suppose if you want to calculate the elongation for AB section, so I have modified this formula: force in AB section, then length of AB section. A, I have not considered A for AB section because the area of all the sections are sum. Because why? We are considering elongation of uniform cross section. Uniform cross section means what? Area of AB, BC and CD, all the section having same area due to the uniformity of that section. That's why I have not considered AB, area for AB section, area for BC section and area for CD section. No, just one area, because area is same. But yes, modulus of elasticity may be different or may be same. That is depend on the section having with us. But most of the cases, the modulus of elasticity of a particular section will be same. So now here we can consider force of AB and length of AB is different, but most of the cases area is same, and in some cases maybe modulus of elasticity will change. Okay, so this is the simple formula that we need to consider for the calculation of numerical. Okay, now general steps to solve such type of numerical. General steps, just keep these steps in your mind, so we can solve any type of numerical. So first thing is what? Find the forces of individual section by taking section in individual bar section. Now it's a self problem. Suppose if we consider this section, okay, let's say suppose A, B, C and D. Okay, so first step is what? Find the forces of individual section, means whatever intermediate or the outer or external forces are given to us. So first we have to calculate the forces in individual section. So just take AB section separately and calculate the individual forces, means the force only are acting on AB section. That is first thing. Okay, second, fixed or find the axial forces of each section as a compressive or the tensile and the length. Then whatever forces we are calculating on particular section, let's say suppose, how to calculate that we will discuss. Let's say suppose you have calculated the force on section AB or the force of section AB. Let's say suppose this force we have calculated direction, how to calculate the direction or how to decide the direction, that we will discuss in the numerical. Okay, so first thing is what? We have calculated the forces on the separate section. Once you calculate the force on the subsection, just decide whether that force is acting on that subsection is a compressive or tensile. Okay, so how we are considering that compressive or force is only for the direction or only for the calculation whether that length will reduce or increase. Because suppose body is subjected to a compressive force, so definitely that body will get a compress, means length will reduce. Similarly, suppose body is acting tensile force, so in that case body will elongate. So change in length is in positive, so it the length of that particular section will increase, so we will consider that sign as a positive. That's why we need to calculate first whether that force is compressive or the tensile force on that particular subsection, and on that basis we will decide whether that force is positive or negative. That is a simple thing. And then calculate total elongation as per the formula that we have discussed. Okay, so this is simple thing that you need to keep in mind while solving the numerical. First is what? For initial calculation, means whatever initial calculations we are doing, means initial calculation means we are calculating first individual forces in each section. So in that case, just consider left force negative and the right force is positive. Means suppose force is going towards left, so consider that force is negative, and if force is going right side, so consider that force as a positive. You can consider vice versa, but we are considering only one rule throughout the subject, now throughout the unit. That's why consider left negative, right positive for the calculation of forces on the individual section or the subsection. Okay, first thing, first note is clear. Second, for the compressive force of individual section, take as a negative, and the tensile force take as a positive. Once you calculate the force on the subsection, once we calculate the force on the subsection, so if the total force on that section is tensile, so we will consider that force as a positive, and if that force is compressive, so we will consider that force as a negative. Okay, only 3 steps are there, so just keep that 3 steps in your mind. You will get the total elongation of this type of numerical. So just let's start with the numerical. First, a steel bar of cross section area 200 mm square is loaded as shown in figure. Okay, this is 21 figure. Find the force on each section and the change in length. Take E equals to 200 gigapascal. See, in this numerical they have given first is area 200 mm square, and the E means modulus of elasticity is given 200 gigapascal for all the bars. Okay, throughout the bar modulus of elasticity is same. And now they they have given 3 forces. First is 50 kilonewton, 20 kilonewton and the 30 kilonewton, where 50 kilonewton is act at A point, external force we can consider. Similarly 30 kilonewton is at C point, it is also external force, but 20 kilonewton is acting at B point, and this force is a 20 kilonewton intermediate force. Okay, then AB, length of AB section is given, that is 300 mm, and the length of BC section is also given, that is 500 mm. So let's start with our numerical. So first step is what? Just consider individual section and calculate the force on the subsection. Correct? Now this is just for reference, no need to write this in numerical in exam. So it is just for your reference and my reference. So first consider section XX. Now here we are starting calculation from A point. You can start that calculation from C point also, because both points are free. So when both points are free, so in that case you can start your calculation from any and no problem. But now for this numerical or such type of numerical, we always start the calculation from the left hand. So from left hand, first section is AB. So just I have considered the one section at B point. Okay, one section at B point, and now I am calculating the force on BC section. AB first section. So section XX, and if I consider left, because I am going left to right, so I will focus on the left part of that particular XX section. So section XX, and left side only one force is there, that is 50 kilonewton. And now just we have considered sign convention. If in the calculation of total force in a subsection, if force is going left side, consider it as a negative, so it's minus 50 kilonewton. Okay, so 50 kilonewton towards left at A point. So the first subsection having 50 kilonewton force at A point towards left. Okay, so now for AB section, just consider left towards left force 50 kilonewton and directly apply 50 kilonewton, means whatever magnitude at here, okay, A point. So directly consider that magnitude on B point, but but directions are different. Suppose the 50 kilonewton is going left, so at B point consider 50 kilonewton as right, and if that 50 kilonewton is towards body, so this is also towards body, away from the body or towards the body, like that also you can consider. Now first sections we have completed. Now we have another section, that is BC. So for BC section, again we have started calculation from left to right, correct? So we will see the left part of that particular section. So on left part, two forces are there, that is 50 kilonewton and 20 kilonewton at B point, correct? So at YY section, 50 is towards left, so it's negative, and 20 it's towards right, so it's positive. So minus 50 plus 20, it's minus 30. So minus 30 means again we have to consider that force towards the left at B point, correct? At B point, because we are calculating, we have calculated that forces for BC subsection, correct? So we will consider that BC force is towards left, correct? Again, as we have discussed for AB section, so if our force at B point is away from the body, so we will consider same magnitude, and that force is also away from the body, correct? So now here our first step is completed. We have calculated the forces in individual section. Two sections are there, AB and BC. So we have calculated the individual forces on AB section and BC section. Now second step is what? Find fixed or find the axial forces in each section and the length. Now here we have calculate individual forces on AB and BC. So just see, if AB section is there, so for AB section tensile forces are acting, correct? Tensile force is there, only one force is there, tensile force is there, that is 50 kilonewton. Okay, so that's why we will consider P1 is equals to 50 kilonewton, and this is a tensile force, so just consider positive kilonewton, positive 50 kilonewton, as we have discussed in the note second. If the force is compressive on your subsection, so it is negative, we will consider that force as a negative, and if the force is away from the body, means tensile force, so that force should be positive. So P force, P1 force means force, axial force on section 1, tensile positive. Similarly P2 means the force, axial force in the second section or on the second section, it is also tensile, so we consider it as a tensile. Okay, so P1 is positive, P2 is positive, because both are tensile forces. Now decide the length. So length is already given in the numerical. AB section having 300 mm and BC section having 500 mm. So L1 and L2, because AB we have considered as a first section and BC is a second section. So now just calculate the total elongation. We know the formula, just calculate the elongation of each subsection, then we will, and then take a sum of all the section, we will get the total elongation of that rod. So total elongation of that rod is delta L1 plus delta L2, where delta L1 is what? PL by AE. Formula is what? PL by AE, where P for first section is 50 and L is 300. Area and the modulus of elasticity is same. Okay, and for second section again P is 30 and L2 is 500. So just put values, we will get the total elongation, that is 0.75 mm. The bar is expand by 0.75. Why we are considering the bar is expand? Because whatever change in length we have calculated over here, okay, whatever change in length we have total change in length we have calculated over here, that change in length is in positive, that's why bar is expand. Okay, and second thing is what? The both subsection having the tensile force Obviously, if any subsection having the tensile forces or any section having the tensile force on that body, the bar will elongate or bar will extend. Okay. Now, second one, a square bar of 25 mm by 25 mm is subjected to axial force at different locations as shown in a figure 19. Find the total elongation of bar if E equals to 200 gigapascal. Now, see, three sections are given A, B, B, C, and C, D. Length of each sections are given 600, 1000, and 1000 mm. Okay, and some axial forces are given 50, 90, 20, and 20 kilonewton. So let's start with the given data. Square bar is given, uniform bar is given. So first we need calculate in the formula PL by AE. So first we will calculate area. So 25 by 25, because we know the area of square bar B into B or B square, correct? So 25 into 25, so area of that uniform cross section, uniform square cross section bar is 625 mm square. E is given 200 gigapascal, so we will consider that one. Now come with next again. Simple, both ends are free. You can start calculation from A point or from D point. But for such type of numerical, we are starting this calculation from the left. So same, consider first section, then focus on the left part of that section. Only one force is there, that is 50 kilonewton, and that 50 kilonewton force is acting towards left, so we consider it as a negative. AB, for AB, left of section XX 50 kilonewton only, and the direction of that 50 kilonewton is towards left. So direction of towards left, so we will consider at AB point or AB section. At A point 50 kilonewton is away from the point, so at similarly at B point we directly consider 50 kilonewton at away from the point. Then next one is again consider next section at the next point. So for BC section, for BC subsection, we will consider the section at C point, correct? So again, left of Y section, left, just focus on the left part of that YY section. So now two forces are there, 50 and 90 kilonewton. So 50 kilonewton is towards left, correct? So 50 kilonewton towards left and 90 kilonewton towards right. So minus 50 plus 90, that is plus 40, correct? Plus 40. Now that final answer is plus, it means we consider the BC section. On the BC section at B point, the this 40 kilonewton is towards right. So for BC section 40 kilonewton is towards right. Okay, so we will consider at B point 40 kilonewton to 40 kilonewton is towards right. Similarly at C point directly apply 40 kilonewton, but direction of that force is towards right, sorry, towards left or towards body. Now BC completed. Now next section is CD. Okay, so for CD section, again CD section we will consider ZZ section at C point, D point, and we'll focus on the left part. Now on left part three forces are there now, 50, 90 and 20 kilonewton. Okay, 50 is towards 50 towards left, negative, 90 towards right, positive, and the 20 towards left again negative. So minus 50 plus 90 minus 20, it's plus 20. The answer is plus 20. Plus 20 means that CD subsection subjected to a force is towards body, correct? So 20 kilonewton towards body for CD section at C point. So we directly consider 20 kilonewton towards body at D point. Okay, now here we have calculated the individual forces of each section. We have three section, 1, 2, 3, and we have calculated the individual forces on each section. Now next step is what? Lengths are given. So let's we consider this is as a L1, this is L2, and this is L3. Now the main important thing is what to calculate the total elongation. Okay, P1, P2, P3, where P1, okay, P1 means axial force on first section, it is tensile, consider positive. P2 means axial force on second subsection, so it's compressive, so consider negative. And P3 means axial force on third section, this force is also compressive, so consider negative. Okay, so P1 positive, P2 negative, and P3 is also negative. And the lengths already are given in the numerical. L1 600, L2 1000, and L3 is 1000. Now find the elongation, total elongation. We know formula, change in length equals to change in length of first section, change in length of second section, and change in length of third section. Just put all the values. Okay, P1 L1 by A E1. Similarly, just put all the values. P1, see here, P1 is 50. Okay, P1 is 50, L1 600. Okay, area is 625, and E is 200 gigapascal. Similarly, put the value of L2, P2, L3, P3, all. But now see here, the important thing is what, our P2 and P3 both are negative, so where we have considered that forces with the sign. Okay, P2 and P3 we have considered forces with the sign. So once we calculate the elongation of individual section, see, the elongation of first section is positive 0.25, second and third section both section having negative forces, so the elongation is in negative, minus 0.32, minus 0.16. And if we consider the total elongation, that total elongation is in negative, minus 0.24 mm. Correct. So negative sign means that total bar is contract. Okay, the total bar is contract, or the bar is contract by, or the bar is reduced by 0.25 mm. Finally answer is positive, but the bar will reduce. That sentence is most important. Okay, now next, third numerical, the axial loaded composite rod shown in figure 23 has a uniform cross section of 500 mm square. Determine its change in length. The moduli of elasticity are EST 200 gigapascal, EAL 70 gigapascal, and ECU 120 gigapascal. See here, cross section, now different numerical is there. The one total bar is given, A, B, C, D, three subsections we can consider over here, and all subsection having the different material. The first AB section having copper, BC section having aluminum, and CD section having steel. Different material are given, intermediate forces are given, and one more important thing or one more change is what, both ends are not free. Here A end is fixed and D end is free. So see, in last two numerical we have seen that both ends are free, so we can start our calculation from left to right or right to left. But now here we have some limitations. Such type of numerical, always start your calculations from the free end, but it means now for this numerical we will start our calculations from the D end. Okay, so we will go through right to left. Why? Because A point is fixed over here. So just write down all the given data. Cross sectional area is uniform, as our title is uniform cross section, so area is same throughout the bar, but modulus of elasticities are different. For steel it's 200, aluminum 70, and the copper is 120. Okay, gigapascal, so we can directly consider kilonewton per mm square. So lengths are again different. Length of copper is 500 mm, length of aluminum 700, and length of steel is 300 mm. Okay, so start. First we will start from right to left. So first section is CD. So for that section we will consider XX section near to the C point, and then we will focus on the left side, sorry, right side of the section, because we have started calculation from the right to left. So on right side only one force is there, that is 50 kilonewton, and that force is away from the D point. So we will consider 50 kilonewton away from the body at D point. So again directly consider 50 kilonewton away from the body at C point. Now next is consider section YY section at B point, and now on the right side there are two forces, 80 kilonewton and 50 kilonewton. So 80 kilonewton is towards left and 50 kilonewton is towards right. So 50 towards right consider positive, and the 80 kilonewton towards left consider negative. So 50 minus 80, that is minus 30 kilonewton. Minus 30 kilonewton means the force, that 30 kilonewton is acting towards left at C point. So if we consider at C point the 30 kilonewton is towards left, means for that particular subsection the 30 kilonewton is towards the body. So we directly consider the force at B point is towards the body, but the magnitude of that force is same as a magnitude of C point, correct? Now last section is there, AB. For AB just consider ZZ section and then focus on right part. So on right part three forces are there, 30 kilonewton, 80 kilonewton and 50 kilonewton, where 50 kilonewton is towards right consider positive, 80 and 30 kilonewton towards left consider negative. So minus 80 minus 30, it's minus 60. Total answer is minus 60 kilonewton. Minus 60 means consider force is towards left at B point. So for AB section we consider left at B point. Left at B point means force is towards body. So at A point also we will consider that force is towards body. Okay. So now here we have calculated the axial forces on the individual section. So on that basis we will consider whether that force is tensile or compressive, and on that basis we decide the sign of that particular axial force on individual section. So AB is tensile. So for CD section 50 kilonewton is tensile. So P1 is 50, positive 50, P2 compressive minus 30, and the P3 compressive minus 60. L1, L2, L3 already given. A steel, that is first section, aluminum second section, and copper third section. Okay, total change in length formula, delta L1 plus delta L2 plus delta L3, where delta L1 is elongation of first section, second section and third section. Okay, just put all the values, we will get answer. First P1 positive, P2 minus 30 negative, and P3 minus 60 negative. So that's why the elongation of first and second section is in negative, and P1 is positive, that's why elongation is positive, but the total elongation of that section is minus 0.95. So 0.95 is in minus, it means the bar is contracted by 0.95 mm. Next numerical on next slide means we will see again some kind of numericals, varieties of numericals on the second part, that is elongation of uniform cross section bar. Again some types of numericals are there, so we will discuss it in next video. But before that I request everyone, please like, subscribe and comment your queries in the comment box. Thank you.